Alright, let's continue with the solutions to our review of skill packet number 4. On these last few problems, they are variation problems. Although they're word problems, you guys have done very well on these. It's a direct substitution looking for key words. When you see that something is directly proportional or it varies directly, then you think multiplication. Y is equal to k times x. K is just simply a constant. As x and y change through the problem, the k remains the same. Some textbooks may use a c for constant, or even an a or a b. When you see that the description of inversely proportional or it varies inversely, think division. Think that y is equal to that constant divided by x. When you see joint variation, that typically implies that there's more than two variables. And think, like, sometimes it'll even say directly proportional to x and y. But when it's jointly proportional, think multiplication. Z is equal to k times x times y. Another one is a combined variation, where within the sentence it'll say direct variation and an inverse variation. So we'll see, I believe, some examples of that. So let's take a look at the problems here that we have. Write the equation that represents the described relation and determine the constant of proportionality. So when we see that first sentence, that r varies directly with t, we think multiplication. K is our constant. So our first equation, r equals k times t. This next information is going to allow us to determine this constant. So when r is 18, this t is 4. So to solve for k, let's divide both sides by 4. Both of these share a common, they're both even, they share a common factor of 2. So I get that k is equal to 9 divided by 2. And so our equation then is, I know what k is, it's 9 over 2. So here is our equation. They'll sometimes refer to that as the model that models this situation, this behavior. Alright. W varies jointly with x and the square of y. So jointly is implying that there's more than two variables. So we have a w, but we also have an x and a y. So we've got three variables. Think directly, think multiplication. So this w is equal to this constant times x. Now, the square of y means y to the second power. Okay, so there's my equation. Now the next information allows me through substitution to determine what this constant is. W is equal to 120. X is equal to 5. Y is equal to 2. 5 times 2 squared is 5 times 4, that's 20. So if we divide both sides by 20, we see that k is equal to 6. So our model then is w is equal to 6 times x times y squared. And we could use this if they then said find w when x is 3 and y is 5. It's just a substitution. Or it could give us any two of the three variables and ask us to solve for the other. Alright, so A varies directly with S and inversely with R, so this is a combination. A varies directly with S, I think K times S, put the S in the numerator, think multiplication. Inversely, that's division, so I'll have S divided by R. Now in this next sentence, it gives me enough information to determine K. So A is equal to 8. S is equal to 12. R is equal to 15. I can reduce that. Both share a common factor of 3. So this is 4 over 5. Now, to get that to cancel, let's multiply both sides by the reciprocal. Let's multiply the reciprocal of 4 over 5 is 5 over 4. If I multiply the right-hand side, I have to multiply the left-hand side. and 5 divided by 5 is 1, and 4 divided by 4 is 1. So see, I just have my k, and 8 times 5 is 40, and 40 divided by 4 is 10. So I have now my model is that A is equal to 10 times S divided by R. Now, in this problem, they're asking us to use that model now to predict what A will be when S is 9 and R is 4. So we just simply substitute in S is 9, R is 4, and we have 10 and 4 share a common factor of 2, so that's 5 over 2. So we have 5 times 9, which is 45 over 2. All right, I believe that's the last one. I hope that helped. Talk to you later. Bye.